Okay, welcome to topic 4, dilations in the coordinate plane. And dilations is just a word that when you take a figure, a triangle, whatever we're working with, and you're going to reduce or enlarge the size of it by a given scale factor. So we're probably going to be working with a lot of triangles, and we're going to take triangles and we're going to either reduce them or enlarge them by whatever factor it tells me to do it by. So we're going to take this given triangle ABC and we're going to do a dilation. And for this one, the scale factor is 2. So I have these points here. I'm just going to pick a new point here. I'm going to call this point here 5, 2, the new point A prime. So I'm going to find the new B prime and the new C prime and draw a new triangle whose sides should be twice as long by the scale factor. So what we're going to do, we're going to count squares. So if I go from here to here, it's up 2 and over 1. So since I have a scale factor of 2, when I come over here, I'm going to go up 4 and over 2 based on the fact that I did 2 times 2 and 1 times 2. So my new point here is this point, and this is B prime. I'm going to do the same thing over here to go from A to C. I'm going to go down this way and over that way. So that was down 3 and over 6. I'm going to multiply those numbers by 2. So it's going to be down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now it's down 6 and over 12 because I did 3 times 2. I did 6 times 2 over here. And this new point is my C prime. And now I'm going to draw the size of my triangle the best I can. And there is my new triangle. This is triangle A prime, B prime, C prime, and its side lengths are twice the original triangle ABC if you look carefully. I'm going to do the same thing with this triangle, except I'm going to start at vertex A, and that will be a fixed point. It will not move. My scale factor is going to be 1/3, but what I need to do is find new points for E prime and B prime. So those are the new points I'm finding. Okay, so if I look carefully, A is going to be fixed. It's not going to move. I'm going to keep this point right here. So if I count my squares, they go from A to E. I look, it's up and over. If I count my squares, it is up 3 and it's over 12. And I'm going to multiply by my scale factor. So 3 times 1/3 is equal to 1, and 12 times 1/3 is equal to 4. So now I have to go up 1 and over 4. Up 1 over 4. And this dot right here is my new E prime dot. I'm going to do the same thing for B. I'm going to count my squares. I notice that it's down 6 and over 9. So I'm going to multiply by my scale factor, so 6 times a third is equal to 2, and 9 times a third is equal to 3. So that means I have to go down 2 and over 3, down 2 and over 3. And this point here is my new B prime. I'm going to pick this dark blue, and now I have a new triangle. That's the side E prime B prime, and I have to do A is fixed, and so there's AB prime, and I come over here, and that's my AE prime, and there's my new triangle that sides are 1/3 the original side. Excuse me. One thing I do notice that the point E prime is on the original line AE, and B prime is also on its original line AB. So even though when I keep a point fixed, when I use one of the vertex as my fixed point, and it shrinks it or enlarges it, those new points will be on the original line segment. So I'm going to do the same thing for this problem that I did for the previous problem, except my scale factor is a different fraction. Now it's scale factor of 3/5, and I'm fixing vertex B. This is a fixed point. It will not move. So what does it mean? I need a new A prime and F prime. Those are the new points I'm trying to find. So again, I'm going to count my squares. So you can see that I counted my squares from point B. I went from B to A, which is over 20 and up 10. If I multiply it by my 3/5 factor, I get 12. And when I do 10 times 3/5, I get 6. So now I have to go over 12 and up 6. And over here I have the same thing, 20 times 3/5 is 12, and 20 times 3/5 is 12. And I'm going to count my new squares from point B. So you can see I plotted my new A prime by starting at B and going over 12 and up 6 for my calculations. And my F prime was over 12 and up 12. And I should be able to connect these. I'll pick a nice color. Pick orange. I'm going to connect everything. And first I connect these pink dots. So that's my new side A prime F prime. And I'm going to start again, still from point B. That's not going to change. So I have BF prime, and this last side is BA prime. And this orange triangle is my new triangle, whose side should be 3/5 the original triangle. So we're going to use this picture to answer some questions on the next page. So we're going to compare triangle BA prime F prime to the original triangle BAF. And the first thing they ask, what's the relationship between these two triangles? Well, they are similar with a scale factor equal to 3/5 if you go little to big. If you want to go the other way, you could say your scale factor is equal to 5/3 if you go from big to little. That's comparing the two triangles, that the orange to the original is like that. What's the relationship between angle FAB and F prime A prime B prime? So angle FAB to F prime A prime B prime. Well, what's going on here? So we're asking to compare this angle, and you could see that they are the same. So they are congruent. And then it's asked the angle between angle AFB and A prime F prime B prime. And let's see, let's go back. AFB is this angle here. And A prime F prime B prime is this angle here. And hopefully you see that these are also congruent angles. And then it's asking about this line AF and A prime F prime. And hopefully you can say that these are parallel. Both have a slope equal to, well, let's count. If I go from this dot to this dot, or this dot to this dot, I see a slope of 1/4. So here's another reason why these two angles are congruent. And the reason that these two angles are congruent is because we have the case of this angle here and this angle here are corresponding angles for both of them. That's why they work. Now let's look at the area. Well, obviously the orange triangle is smaller than the original triangle outlined in black. But when we talk about area, so we're doing the big over little when we talk about ABF, A prime B, F prime, and that scale factor is 5/3. But when we talk about area, we don't leave it as 5/3. We have to square it, and the ratio of the area will be 25/9. The scale factor squared. Area is always a squaring of something. So I want to compare this big triangle ABC to the smaller triangle AEF, and they are similar to each other. So we have to figure out the scale factor. So when we figure out the scale factor is figure out, well, how much do we have to go over? Or how much do we have to go up? So if I look at this carefully right now, it's up 7 and over 21 when I count squares. Well, I could even count 17 to -4 is 21, and from 3 to -4 is 7. But I want to do this point here. So if I go to this point here, a little bit harder to see. This one is definitely over 7, and it's up, I don't know, there's a fraction involved. I don't know, it's like 2 1/3 or something like that. I might not use that one. I'm not a big fan of that one. But one thing I do have, I have a nice, one side is over 7, the other side is over 21, so I can set up a scale factor. I'm going to be little over big of 7 over 21. So my scale factor is equal to 1/3. Now if I did it the other way around, big over little, the scale factor would be 3. And if you look carefully, if we do 7 times 1/3, you get 7/3, and that's what that number is there anyways. 2 1/3 is 7/3. So the next problem, I have a scale factor of 1/4, starting at vertex A. That means vertex A is fixed. And then I'm going to make sure side AB, I'm going to multiply by 1/4, and side AC, I'm going to multiply by 1/4 by counting my squares. So I did my little boxes where I went down and over, or up and over, and I see down 8. So I do 8 times 1/4, I get 2. I do over 4 times 1/4, I get 1. That means I have to go down 2 over 1. And here's my point right here. And for this one, well, 20 times a fourth is equal to 5. And 4 times a fourth is equal to 1 because I'm always using my scale factor. So I have to go over 5. 1, 2, 3, 4, 5. And down 1. That's my new point. So this point here is B prime. This point here is C prime. And I'm going to draw my triangle. And my thing went away. So here I go. I'm using a straight edge. That's why it's taking me a second to do this. So I have my triangle A, B prime, C prime. In red here, right here. So let's look to see what we got going. The one thing I do know, let's make some conclusions, is for length, AB prime is equal to 1/4 the length of AB. It's 1/4 the size. Again, for length, I have AC prime is equal to 1/4 the length of AC. And then this other side right here, I have B prime C prime is also 1/4 of that long side BC, this long side here at the bottom. But the other thing I really see is that B prime C prime, oh, that's terrible. If I look at line B prime C prime and compare it to line BC, they are parallel to each other. What does that mean? Well, that means that angle AB prime C prime is congruent to angle ABC. These angles here by corresponding angles. And then also this angle here and this angle here. So angle AC prime B prime is congruent to angle ACB, again by corresponding angles. And let's talk about perimeter. Perimeter of triangle A, B prime, C prime is equal to 1/4 the perimeter of triangle ABC. But when we talk about area, area is different. The area of triangle A, B prime, C prime is equal to 1/16 of the area of triangle ABC, because I have to do not 1/4, but 1/4 squared. Area is always a squaring relationship. So we've been working on doing scale factors from a given point, one of the vertex on the triangle. How about if it's about the origin, which is not the vertex? Well, this is actually a little bit easier because all you have to do is multiply all the x's and y's by whatever the scale factor is. So in this case, by a half. So when I'm at point A, that point is -4, 4. I'm at point B, that is 6, 0. And point C is 2, -6. And all I have to do is multiply all the x's and y's by my scale factor of a half, and I get new results. So -4, 4 times a half is going to be -2, 2. 6, 0 by a half is going to be 3, 0. And 2, -6 by a half is going to be 1, -3. And all I have to do is plot those new points. -2, 2. 3, 0. 1, -3. And I'm going to call them A prime, B prime, and C prime. And I'm going to draw the new triangle inside of it. There's my new triangle, A prime, B prime, C prime. And if I notice, the perimeter of triangle A prime, B prime, C prime is equal to half the perimeter of triangle ABC, because that's a scale factor. But again, the area of triangle A prime, B prime, C prime is going to be 1/4 the area of triangle ABC, based on the fact that it's not the scale factor of half, it's a half squared. We always have to incorporate a squaring when we do area. So this is the same type of problem as hit before, except our scale factor is not 2 instead of a half, so we're multiplying all the x's and y's by 2. So negative 4, 4 becomes negative 8, 8. 6, 0 becomes 12, 0. And 2, negative 6 becomes 4, negative 12. And I'm going to plot all these points. Negative 8, 8 is right here. That's my A prime. 12, 0 is here. That's my B prime. And 4, negative 12 is here. That is my C prime. And I'm going to connect the 3 dots to make the new triangle. So I drew the sides of the new triangle, A prime, B prime, C prime. You can see the sides are twice as long as before. So my perimeter is twice the perimeter of triangle ABC. But the area is not going to be twice. The area is going to be 4 times the area of triangle ABC, because of the scale factor is 2, but area is always a squaring. 2 squared is 4. Okay, please ask questions during class. We'll go through notes and we'll do some problems. Thank you for watching this video.